I'm Mark Sponsler, and welcome to the Storm Surf Video Surf Forecast for the week starting Sunday, June 14th. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights, we see remnants of a gale east of New Zealand, almost over the central South Pacific, not really doing anything, producing 25-foot seas aimed well to the north, producing swell that will probably move into Tahiti, and maybe some energy for Hawaii, and also the U.S. West Coast, but not from this, from when it was a little bit stronger under New Zealand. Otherwise, nothing significant is going on in the South Pacific Ocean. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough that is a push in the southern branch of the jet stream. That's it right here. That's the northern branch there. Pushing up to the north. Look right there. So what that helps do is create a clockwise flow aloft and down at the ocean surface. And that's the hallmark of low pressure in the southern hemisphere. And low pressure, if it is strong enough and deep enough, helps produce winds, and winds, if they're strong enough, generate seas, and seas, if they're large enough, start radiating north and eventually turn into swell, and swell, if it's big enough when it hits your beach, turns into surf. All right, so we have a trough here, but it's kind of cut off, kind of pinched, right? And not offering a whole lot in terms of gale production. We know there are some seas in the 25-foot range in this area, but notice here, the jet is pushing hard to the south under New Zealand. That's a ridge. That basically does the exact opposite of trough. It creates high pressure down at the ocean surface and pretty much squashes support for storm production. So we have a ridge here and a ridge here and a tiny pinched, almost cut off trough in between. Broader trough now off of Chile, but outside of our forecast area, that is the California and Hawaii swell windows. All right, so that's where we are now. Let's put this into motion, see where we're going. Moving into Monday, the trough pretty much dissipates relative to, anything that we care about. And the trough off Chile continues, but no real support for storm production. And then we continue into Tuesday. The ridge moderates some, but still you see southbound winds. You see winds over Antarctica. You see no sign of a trough. That's not a good sign. As we get into Wednesday, more of the same thing. A trough tries to form in the far southeast Pacific, but outside the California swell window, doing nothing there. Another big trough, another ridge starts sweeping in out of the west on Thursday evening. Not looking so good until you get till about Saturday. And then notice, this is the beginnings of a trough start setting up. Winds pushing to the northeast at 140 knots, offering some support for gale development. And that continues sweeping east into Saturday night, and then reinforced by more wind energy at about 130 knots. So we get into Sunday night, and almost into Monday. So maybe a week out, looks like there might be some support for gale development, but nothing super clear-cut. So let's go take a look at surface level pressure and surface level winds. Now, as expected, high pressure here. We know there's a ridge pushing south. You can actually see at the surface winds pushing to the south. That does nothing for us. We want winds to the north, like there, but we need them stronger. That's 30 to 35 knots. We know there's 25-foot seas in that area. There's also this gale. This is part of a complex gale situation here, but these winds are mainly aimed southeast. That means any swell generated by them will be tracking off to the southeast at Antarctica, or at best maybe southern Chile. Again, of no real interest. So we start putting this into motion, looking for something. There's some tiny patch of 45 knot winds on Monday night, but they're not really doing a whole lot and quickly moving out of the California swell window. Here comes a gale on Tuesday night, Wednesday. There we go, 45 knot winds. Now the ice line, it's just about the dead of winter in the southern hemisphere. Ice line's like 65 south. We'll take a look when we get to the wind models, but this is right on the hairy edge of the ice line, and all the fetch is aimed off to the east. From previous videos, we like to see fetch pushing more off to the northeast. The easterly fetch, you do get some sideband swell, and actually that's not bad. 45 knot winds, again, pushing due off to the east. And continuing, I mean, nothing super impressive there. Another broader gale forecast setting up. We know there's a trough developing under New Zealand as we get into Friday. And there's a broader area of 40 to 45 knot winds with a little bit of a southwesterly component and better southwesterly winds, theoretically, as we get into Friday night and Saturday. Lifting off to the northeast, that offers some hope for sure. So we get into Saturday, and more fetch even behind that. On Sunday, again, kind of more easterly aimed than northeasterly aimed, but any angle off to the north is good, and that's the end of the model run. So, some hope, but again, it looks like it's about a week out, and a lot can change in a week time. So let's take a look at the wave models, see what's going on. So this is back Monday, almost a week ago. Little primer gale pushed under New Zealand with 20, 22, 24, 27-foot seas aimed off to the east, building to 30 feet. That roughed up the surface pretty good. And then another stronger gale pushed in behind with 40-foot seas, now a long ways away, but clearly pushing into the California and even Hawaii swell window with 38-foot seas by Tuesday morning, and then fading from there, not getting not a whole lot of northward trajectory to it, but still capable of producing small swell. And then we go into the week, another gale developed. Now, this was supposed to be a really interesting one. On Friday, at least last week when we were watching the models, was supposed to push under New Zealand, start building, and then lift well to the north. And when with, at one point, I think it was 36 seas aimed due north, that would have been a great swell producer. Well, here's what happened. It built 30-foot seas on Friday night into early Saturday, and then started to do the north lift thing and just fell apart. 20, 22, 24-foot seas. You can get maybe a 14-second period from that, and that will decay pretty well as it starts lifting north. Now, swell for sure for Tahiti, some energy for Hawaii, something for the U.S. West Coast, but nowhere near as strong as it looked at one point in time. So that's where we are today. So looking forward, we'll see what happens here. Now we know our fading little gale starts falling apart. A little bit of easterly fetch there, again aimed at Chile, maybe Peru, but nothing for our main forecast area. Then a small gale is forecast on Wednesday, developing under New Zealand. Oh, ice line inspection, here we go. 63 south, that's well to the north, and then falling to about 65 south as you get southeast of New Zealand, something like that. So a little bit of fetch here, probably seas pushing 40 feet theoretically on Wednesday night, and then crashing into the ice, pretty much getting scraped out. Doubtful that'll happen, and doubtful much swell will result, especially given its eastward trajectory. Now another gale is forecast behind that on Friday, generating, about 34-foot seas, building in coverage to 38 feet, and then 40 feet, and then, about 41 feet, and lifting off to the northeast as we get into Saturday, and continuing a little bit off to the northeast through Sunday before fading, with secondary fetch behind that. If this were to happen, we could get a pretty decent amount of swell. Now, it's not aimed perfectly off to the northeast, but enough that probably a good run of decently rideable surf could result for Hawaii, of course Tahiti, U.S. West Coast, down into Central and South America. The real issue is this is a week out. Well, let's see, actually, when is it supposed to start forming on? We'll give it sometime on Friday, so at least 5 days away. We'll see whether this really happens. The last gale, just like we said, that was supposed to do this, it pretty much never even materialized. So the models... So when you're in sort of a La Nina type thing, the models seem biased more towards a neutral pattern. La Nina tends to stomp on the trend long term. El Nino, the flip side, reverses. The models tend to undercall it. Yes, the models account for El Nino, La Nina to some degree, but just the same, it seems just from years of watching, they tend, at least this model tends to be over-biased or over-hyped on the La Nina modes and underhyped on the El Nino modes. So we'll have to wait and see what really happens. Nothing's going on in the North Pacific of any interest, but we'll look for wind swell. So currently, winds blowing. Here we go. There we are. 4 o'clock on Sunday evening. Winds 15-20 knots along the California coast. Yeah, making for some wind swell. There's barely rideable wind swell in the San Francisco area. East winds picking up along the Hawaiian Islands. I think there's some chest-high wind swell on east-facing shores, something like that. Pretty blown. As we get into Monday, the focus remains on Hawaii. This is interesting. A little bit of 25-knot fetch off of Oregon. Maybe that'll make some more wind swell into California. Also notice a little bit of a gale here, supposedly in the Gulf of Alaska in mid-June. I'll believe that when we see it. Anyway, Tuesday, here we go. This big high pressure setting up 1032 millibar high, clockwise flow along around it, as always with high pressure, sweeping down the California coast, generating wind swell, and also pushing from California over Hawaii, generating more east wind swell there. Notice the fetch really picking up on Wednesday, 20 to 25 knots on the North California coast. That's good for producing wind swell into Central California. Notice the fetch pulls away from the Central California coast. This probably would open up the potential for an eddy flow. That would be south winds into Central California, but not quite yet. Let's see where we get on Thursday. 30-knot winds, and this would, the model doesn't show it, but when you get into the higher res models, you actually get this. So there's actually like low pressure right here. Okay, and low pressure would circulate that way, and what happens is it sort of sets up a south flow right along like Central California up into Monterey Bay, up into Half Moon Bay, San Francisco, that sort of thing. And the model actually sort of picks it up as we get into Thursday night, Friday. Good wind swell potential. East trade wind swell fading for Hawaii. More wind swell as we get into Saturday, though that quickly evaporates. And then more east wind swell for Hawaii, but nothing too significant as we get into Sunday, though it looks like another gradient trying to build Sunday night relative to California. Also notice, theoretically, do you believe that? What is that? 40-knot northwest winds in the Gulf of Alaska on the 22nd of June? Not a chance. All right, so let's go take a look long-term. What's going on with the Madden-Julian oscillation and, of course, El Nino or La Nina. So as usual, we first off like to examine looking for the presence of the MJO, the Madden-Julian oscillation, a periodic weather oscillation. It traverses around the planet from west to east on the equator. Takes about 3 or 4 weeks to make its traverse from the West Pacific to the East Pacific. When in the active phase, it suppresses trade winds. When in the inactive phase, it increases trade winds. So it's basically the active phase is like low pressure that takes a 3-week venture on the equator across the Pacific. And when it does that, it stomps on the trade winds and also imparts energy to the jet stream, helps fuel storm development, most noticeable during the winter months in the Gulf of Alaska. But in summer months, it also helps feed the jet stream down in the southern hemisphere, but not as tightly coupled as in the winter months. All right, so what are we looking at here? This is a chart, wind speeds. We're just looking at the arrows. The other data here, the colors are water temperatures in centigrade. But we're just looking at winds. This is 5-day average winds from a series of buoys, the TAO buoy array. Series of buoys strung across the equator used for monitoring El Nino. This is the equator. This is the West Pacific here. That's New Guinea. There is the date line there. This is the far East Pacific. All right, so the arrows obviously indicating strong trades over the East Pacific, over the Central Pacific, and in this thing we call the Kelvin wave generation area, from 5 north to 5 south, from the far West Pacific, 135 east out to about 170 west. When you have a reversal of trades or a dampening of trades in this area, typically during the active phase of the MJO, and winds either die or turn westerly, they'll actually take warm water from here, start pushing off to the east. It'll create a bubble of warm water that travels not on the ocean surface, but underneath the equator. Takes about 3 months, maybe 4 months, and then eventually, if it has enough momentum, will erupt along the coast of Ecuador, creating a warm pool here. If you get successive Kelvin waves driven by successive active phases of the MJO, that's how you start El Nino. All right. Likewise, if you have La Nina, which we kind of think is what's going on right now, you get stronger than normal trades. The MJO kind of fades out, and basically you get upwelling, cooler temperatures, no Kelvin waves, and the whole cycle shuts down. All right. So it's not so much the actual winds, it's the anomalies. What's that mean? That means the difference from normal for this time of the year. All right. So yeah, we know we have strong east winds here. Looking at these arrows, just 5 degrees north and south of the equator, we see, yeah, that's pretty much normal. Maybe a little bit of an easterly tendency here, a little bit stronger than normal in this region out of the east. And then you get into the Kelvin wave generation area, also stronger than normal there. So east winds are blowing pretty solid. That would be a suggestive of the inactive phase of the MJO. Next off, let's go take a look at the forecast. All right, so most of you know this drill, but for those that don't, this is the whole planet on one chart. So where's the Pacific? Okay, the Pacific starts about 135 east here. This is on the equator. These are just, okay, and the far east Pacific, about 80 west, that would be Ecuador, right? And you draw a line up there in your mind, and a line right up there in your mind, and this is winds. The blues are easterly anomalies, the yellows, reds are westerly anomalies. You can see here back in May, strong easterly anomalies. That would be a strong inactive phase of the MJO. Then it kind of fell apart as we got into late May. But still, this persistent kind of easterly wind pattern in the Kelvin wave generation area. Again, from here to about here. You go down and all of a sudden you see blues again. Looks like the inactive phase of the MJO starting today and holding for the next 7 days, though maybe getting a little bit weaker with little patches of westerly anomalies trying to build, but still suggestive of inactive MJO in control. And if you really look at this, the only real westerly anomalies that have occurred in the past month have been over the Indian Ocean. They never made it into the Pacific. This, again, has that smell of the dominance of easterly anomalies. It's not even the dominance of the inactive phase of the MJO. It's just a preponderance of easterly anomalies, which acts like a long-running inactive phase of the MJO. And that's what this sort of basically looks like, is La Nina in control. All right, so rather than 1 week out, let's go 2 weeks out. And what we're looking at now is outgoing long-wave radiation. Fancy words for cloud cover. More clouds, that would be the blues here, negative anomalies, less sunlight reflectivity off the ocean surface. That would suggest where the active phase of the MJO is. The yellows, more sunlight reflectivity, high pressure, the inactive phase of the MJO. And of course, there is South America, Central America, Mexico, Australia, New Guinea, the equator running right through the middle, date line right there. 4 different panes, day 0, day 5, day 10, day 15. Inactive phase of the MJO, very weak, continuing 5 days out, continuing 10 days out. Active phase still in the Indian Ocean, trying to seep into the far west Pacific. That gives us some hope, but this is the statistic model. One type of model, we'll just say it that way. And then there's the GEFS model, which is a dynamic model, paints a less rosy picture, suggesting inactive phase, inactive phase, inactive phase, and yet stronger inactive phase at day 15. So here we go. I think we can get both these on the same frame at the same time, just barely. There we go. So statistic model says trending towards the active phase. Dynamic model trending towards the inactive phase. What we've seen is in these sort of scenarios, it's typically somewhere halfway in between, which basically would be a dead neutral MJO pattern 2 weeks from now. So that doesn't really give us any hope. Let's keep digging. Phase diagrams. All right, so what are we looking at here? This chart, assume this circle is the North Pole. You're looking down on the North Pole from on top of our planet, and the MJO, or the equator, is out here around the edges, and the MJO moves from west to east, from the Indian Ocean, over the maritime continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The dot, the heavy dot here, is where the active phase is at the moment, so it's in the Indian Ocean. We'll call it the Eastern Indian Ocean. The closer the heavy dot is to the circle, the weaker the MJO is. If the dot were way out here, it'd be much stronger. So a weak active phase of the MJO in the Indian Ocean. The inactive phase is on the other side of the chart in the middle of the West Pacific. No surprise there. The trend, here's the 15-day trend. Active phase, the MJO moving to the maritime continent and collapsing by two of the members, getting stronger by one. This per the statistic model. The dynamic model shows virtually no change. Active phase remaining very weak, balled up in the Indian Ocean, going nowhere 2 weeks from now. So no hope there either. And then the upper level model. This goes out 40 days. Okay, South America there, Central America there, New Guinea, Australia, Philippines, the equator, 0 degrees, right down the middle. The date line, somewhere right around there. Kelvin wave generation area right in here. That's what we're mainly interested in. All right, so the yellow, this is upper level, jet stream level. Oranges, yellows suggest areas of no precipitation, not favorable for precipitation. The greens, favorable for precipitation. So this would be the inactive phase of the MJO moving into the far west, moving over Central America. The active phase of the MJO in the Indian Ocean. All right, and each one of these panels is 5 days out, so you can kind of see inactive phase disappearing. Suppose, and this is a statistical model, we think, a weak active pattern setting up in the Pacific from now until moving almost to the end of the model, till, what is that, July 24th? But the inactive phase of the MJO moving over the Kelvin wave generation area about mid-July and then shutting things down. So theoretically, per the statistic model, we're moving into a more favorable pattern, but very weakly favorable. You also notice here the active phase, if that's what this is very weak, where the inactive phase is stronger and stronger. Again, this tips the hat towards a La Nina style pattern. And then the CFS model, 1 month out forecast. Again, whole planet on one chart. Kelvin wave generation area starts about 135 east right there and ends at about 170 west right there. Here's where we are today in the Kelvin wave generation area. Sort of this mix of east anomalies and west anomalies on the far eastern end of the Kelvin wave generation area, but that doesn't really matter because you look at the forecast, the blues are easterly anomalies. Their forecast taking over the Kelvin wave generation area a week from now, building pretty strong June 27th, and then fading some. So this is a dynamic model, contrary to the previous model, which was more a statistic model. So you see the spread here where the previous model showed sort of a weak active phase during this whole time stretch. This model shows a weak to moderate inactive phase. And we're again going to say probably the dynamic model has a better handle on things. And then we go out even further. Same model, CFS model, but this goes out 3 months. Of course, we don't believe a model going out 5 days, much less 3 months. But believe it or not, this model has done a pretty good job at the high level, the macro level picture. You don't use it for details. Anyway, Pacific, you see that kind of shaded line right there? That's the East Pacific there. West Pacific starts right down along here. All right, Kelvin wave generation area from here to about here. Now, this is past performance here. We're just kind of ignore that. You kind of see the building prevalence of easterly anomalies. The forecast is eyeballing this. If this area here is the Pacific, I see nothing but blues, which are easterly anomalies, except a little incursion of weak westerly anomalies somewhere in the mid-July time frame. Let's overlay the MJO. Okay, no big surprise. The dotted contour here, this is the inactive phase of the MJO, taking over from now until, about July 24th, when the active phase supposedly sets up. But notice, even in this active phase, you have easterly anomalies, just this little shadow of westerly anomalies barely reaching into the Pacific. And as soon as the active phase fades, boom, easterly anomalies set up yet again. And we'll just pull this away, and if you just look, you can just see whole Pacific basically filled with easterly anomalies from now for the foreseeable future. Why would that be? Well, we've been talking this La Nina thing. Let's look at the low-pass filter. This really tells the whole story here. The dotted contour would be the equivalent of like a weak high-pressure bias. Notice back in May, April, March, low pressure bias was in the Pacific. Now, you would think this was almost like a La Nina signal, which it is, but there were other things going on and it was fading the whole while. It went from 2 contours to 1 contour to nothing. And then yesterday, basically we had a flip. Notice this. It was low pressure in the Pacific. This is the Indian Ocean here, high pressure. And what's the forecast say? High pressure setting up in the Pacific over the dateline, which is typical La Nina sort of thing. And then you get this low pressure bias building in the Indian Ocean. And notice in the Pacific, it's not only just 1 contour, not only 2, but 3 contours per today's run of the model. Now, let's be clear. 2 days ago, it didn't have this. It was 2 contours, I think. So, there's a lot of noise in the model. It changes around. It's trying to figure out, get a handle on what's going on. Again, we're talking 3 months out, so it's no surprise. And then a 2 contour low pressure bias in the Indian Ocean. Clear signals of La Nina setting up in the Pacific, and that only gets us to September. The expectation is this pattern will only build as we get into the fall. So enough of the MJO thing, though. Just looking at the charts, we already see this just complete bias towards La Nina, not towards Kelvin wave generation, not towards the active phase of the MJO, but more the inactive phase of the MJO. Let's go take a look in the ocean, see what the ocean thinks is going on. TAO buoy data again, West Pacific here, East Pacific here. These are the anchor lines on the TAO buoys. The X's are the sensors on those anchor lines. They give us subsurface down to 300 meters. So what's that down? About 900 feet, a little bit more than that, 1,000 feet. Give us water temperature data at depth. And remember we talked about Kelvin waves. Warm water in the West Pacific, 30 degrees centigrade. Multiply that times 1.8 and add 32 degrees to it, and you get the subsurface water temperature. And when we said you get the active phase of the MJO pushing over the West Pacific, it creates westerly anomalies. It would take this warm water, start pushing it at depth across the Pacific, and it would eventually erupt over Ecuador. All right, well, we're looking at the profile here, and we're looking for either the tendency or the presence of warm water moving off to the east in Kelvin waves. We see warm water at 30 degrees. It's on the 160 east isotherm line. I think earlier this week it was at 162 or 3. So it's actually backtracking a little. 29 degree isotherm at 175 west. It was actually at 173 2 days ago, so it's backtracking a little. 28 degree isotherm at 57, something like that. That's about steady. And the 24 degree isotherm, so even a month ago, it was pushing into Ecuador. It's completely backtracked. It's at 123, 124 west, so that's like due south of California, suggesting that easterly winds are blowing stronger than normal, preventing Kelvin waves from forming, allowing cool water subsurface here to upwell to the surface off the coast of Peru and Central America, which are typical signs of La Nina. All right, now it's not the actual means, it is the anomalies, differences from normal for this time of year. All right, and no big surprise here. Little bit of warm water, we'll call it 1 degree centigrade, positive anomalies in the far West Pacific. Neutral temperatures reaching to, what is that? About 145 west, so a little bit east of Hawaii on the equator. But then cool water, 2 degrees, 3 degrees below normal, big patch, erupting to the surface with a channel from somewhere allowing more of it at depth to flow into this. And you can actually see you get a little highlight there of cool water seeping up from depth, continuing to fill this pocket. Now this was actually stronger 3 weeks ago. It was broad pocket of -3 degrees, but you could see this thing coming for a month. It is fully erupting to the surface now, and when we start talking surface temperatures, you'll see the effect of this. So we're using a different model on this image, same raw data, basically the same picture, cool water, but 1, 2, 3, 4, 5, 6 or 7 degrees, 1, 2, 3, 4, 5, 6, little pockets of 5 degree, we'll call it, below normal temperatures. Cool water completely taking over the eastern Pacific at depth down 150 meters, upwelling to the surface, and going, well, the date line is right there. You get the idea. Basically, the entire eastern Pacific at depth, cool water, and making its way to the surface on the equator. So sea level height is kind of a hard chart to read, but that's South America there, Central America, Mexico up into there. This is the date line here. The equator's right here, New Guinea there. So that rather than, it looks like temperatures, but it's not. It's the height of the ocean surface, -5 centimeters, -10 centimeters. So what this is saying, there's a depression on the ocean surface, a little indentation. I mean, what, that much? But the satellite is extremely accurate. It basically, JSON satellite strips out all the swell, the waves, wind waves, the tides, and then compares it to heights from normal. And that's how you determine there's a depression here. What's that mean? Cool water at depth contracts, warm water expands. So if there's cool water below the equator, it'll contract and it'll create a little indentation on the ocean surface. That's exactly what this is saying. It's also saying that cool water runs the whole way down the coast of Chile and is now building up into Central America. And what you get is this kind of cool depressed triangle here. That's the classic La Nina kind of symbol or symptom, and this suggests exactly that. And this chart really tells the story. This is West Pacific here, and you notice time, July a year ago up to June this year. This is the East Pacific here. This is upper ocean, upper 300 meters of the ocean surface temperature over time. So you can see, it's like last summer, little Kelvin wave, another little Kelvin wave, but they didn't have much energy to them, and they kind of stalled. You got this cool upwelling off of Central America, right? And it's sort of a repeat of what's going on now. And then in September, whoa, a Kelvin wave showed up, actually pushed the whole way across the Pacific, made it to Ecuador, created some upwelling, started warming temperatures on the equator. Another Kelvin wave, actually 2 active phases of the MJO. Kelvin wave kind of stalled. It got reinforcements. Barely, didn't even make it to Ecuador, but close enough. And it sort of looked like, hey, we're kind of in an El Nino-ish sort of pattern last winter, though, for a host of other reasons. And it was mainly this cool water off of Ecuador. And that lasted from June, July, August, September, almost into mid-October. What that did is that was there long enough that it sort of took the jet stream and made it start moving towards a La Nina pattern. And also notice these Kelvin waves were not very strong. They were weak. There wasn't a lot of energy. There wasn't a lot of active phase westerly wind anomaly energy. There wasn't a lot of warm water here anyway. And so it made it sort of look like we're moving toward El Nino. But because we had months of cool water in the East Pacific, we didn't get the rainfall, we didn't get the swell, the jet stream didn't do its thing. And then here we come this year, and the same thing as last year is happening at almost the same time, but starting in April, but a much stronger cooling, upwelling type signature. And, you know, and the belief is this is going to go on all summer. If that happens as we get into winter, even if we don't get an official La Nina, the expectation is the jet stream is just going to be, you know, it won't have any fuel, it won't have any momentum, it can't reverse itself, and we don't foresee that there's going to be some significant increase. You look at the models, you don't see any sign of the active phase waking up magically and getting strong anytime soon. So there will be no push to the jet stream, which suggests perfect timing for some sort of La Nina-like pattern as we get into the fall and winter. All right, so what's going on at the ocean surface? Enough subsurface. We know for sure the atmosphere and the MJO thing's falling apart. We know for sure that subsurface-wise, we have a bunch of cold water upwelling. At the surface, situation, no big surprise. Now, this is not 2 streams, it's 1 stream. The images just don't line up correctly, but you get the idea. There's Ecuador there, this big stream of cool water from Ecuador almost the whole way out to the date line. And last week when we did this, there was still lingering warm water off of Peru. You see now cool water starting to build, or cooler than normal water. This is anomalies, differences from normal for this time of year. So this big cool water signature on the equator the whole way across the Pacific, suggestive of 1, stronger than normal easterly anomalies creating upwelling, and 2, masses of cold water subsurface being drawn to the surface by those easterly winds. That's typical La Nina setup. The trend for the past week, so the blues are cooler than normal temperatures or trending cooler, and no big surprise. Cool water down off of Peru, off of Ecuador, over the Galapagos, cooling the whole way out to about a point not quite south of Hawaii. Now there's these pockets of warming, but no big surprise. It's cool. Temperatures are they're still cold. They're pretty cold right now, as you saw in the previous image, and they're getting colder still. And the other part is you have a mirror image of this thing going on off Africa as well. That suggests there's some sort of coupled pattern going on here in the Atlantic and the Pacific. That is favorable for La Nina buildup in the Pacific. It's also favorable for hurricane production in the Atlantic, because what it does is in a La Nina pattern, it strengthens. So there's a semi-permanent high pressure off of California, a semi-permanent high pressure off of South America. So it rotates clockwise in the northern hemisphere, counterclockwise in the southern hemisphere. If you're in La Nina, they're stronger than normal. That means trades are stronger than normal. You get more upwelling here. And then the same thing happens in the Pacific, but the high pressure here is driving trades this way, aloft and in the upper atmosphere, and the same thing down here. And what that does is the atmosphere gets stacked straight up and down. It's not like the jet stream here is cutting through and cutting the tops off of developing tropical systems. If anything, it allows them to form and creates a nice vertical chimney to evacuate warm sea surface temperatures up through the chimney of the hurricane, the eye of the storm. And that's what hurricanes are. Basically, they're chimneys trying to that allow warm temperatures to escape from low into the atmosphere up into the upper atmosphere. They're a vent, basically. Okay, it's the way the Earth's atmosphere tries to regulate temperatures is by forming hurricanes. And to a certain extent, El Nino and La Nina are the exact same thing, just using a different mechanism. Anyway, you see the global connection, at least at this, and this isn't the first time we've seen this, where you get the same pattern setting up in the Atlantic and the Pacific. And then the backed off view. Sea surface temperature anomalies, clear La Nina cool pool signature right here. When it's really mature, and it doesn't normally mature till Thanksgiving to Christmas time frame, you'll see cool waters building, sort of an anvil type thing right along here, triangle. And also see that signal off of Africa for the moment now. So definite suggestions of a developing La Nina in flight. Sea surface temperatures in the Nino 1.2 region. This is the area right off of the Galapagos and Ecuador down into Peru. The trend, it's not the absolute values, but today the value is minus 1.423 degrees. Okay, that's pretty low. And the trend, steadily downward. Now, this is the noisy area, so we could say, okay, well, that doesn't really mean anything. It's just kind of noise. But then you go look at the Nino 3.4 region, which is the official El Nino monitoring region. You see temperatures also on a steady decline. They were down at minus 0.59 degrees back mid-May or so, late May. Kind of rebound a little bit today at a third of a degree below normal, 0.314. The expectation is that's going to continue to fall. You saw all the previous data. We'll see how this plays out, but that's our expectation. So when temperatures in the Nino 3.4 region get down to half a degree below normal right there, and they have to stay there for 5 consecutive months, then you get what's known as La Nina, or that's one of the indicators of La Nina. So we're not in that range yet, but the trend is definitely in that direction. All right, one other bit of data. What's going on in the atmosphere? We talked about subsurface ocean temperatures. We talked about surface ocean temperatures. Now what's going on? Does the air above that feel or notice that there's a cold La Nina pattern setting up? All right, so difference in pressure between Darwin, Australia, and Tahiti. Southern Oscillation Index. When pressure is lower over Tahiti, which is basically saying lower over the Pacific, then that would be a sign of the active phase of the MJO, and if it lasts long enough, El Nino. The reverse is also true. When pressure is higher over Tahiti, the index goes positive, and that's a sign of La Nina. Today's value, minus 8.44, but we've been positive, we were pretty negative there for a pretty good 5-6 day run, but that was due to a tropical system passing directly over Tahiti. Prior to that, it's been kind of a mixed bag of positive and warm. All right, so we'll take some of the noise out of this. 30-day average. Today's value minus 2.37. So we're not even neutral yet. We're still kind of in that weak El Nino-ish territory. And we were actually positive there back in late May, just looking. So we think what's happening is this short little burst of very negative numbers push the average down negative, but we expect that to move back to positive. 90-day average takes even more noise out, minus 2.42. Where have we been? We've been hovering about -1, -2 for the whole past month. A little drop lately, again, probably attributable to this. We expect this to continue moving in a positive direction. Let's go look at the trend real quick. All right, the 30-day moving Southern Oscillation Index trend. Here's where we are today. What is it, minus 0.3 or something like that. And the trend, well, you can see since April of last year, we've been heading steadily upward, but not strongly so. When you're positive, again, that's La Nina. When you're negative, El Nino, we're hovering right at 0 today. So these downward spikes are the active phase of the MJO. The upward spikes are the inactive phase of the MJO. So we just finished in a active phase. It looks like we're starting to move into an inactive phase. Now, to put things in perspective, back in 2018, here was we were in this is the peak of a, for sure, La Nina type pattern, and we were peaking at times up to 12-15, positive 12-15, and we sort of muddled along. And then remember last year we said it kind of looked like we're moving to El Nino, but not really, and that's the case. And now we're moving back up. The question is, how high will we go? We're only in the early stages of La Nina development. That cool pool on the ocean surface has only been there for a month or something like that, and we think it's going to hang out till December at least. So we'll see where we go. Early to say, too early to predict, though certainly nowhere near El Nino. And finally, the sea surface temperature trend forecast for the official El Nino monitoring region, the Nino 3.4 region per the CFS version 2 model. All right, so we are, where are we? Middle of June, somewhere right there. This model, again, last year, that warm trend last year, and it predicted this downward trend months ago. I think it started in February, suggesting a significant downward trend, and that's exactly where we are, this model. Yeah, I'll give it 2 thumbs up for being way ahead of every other model. By July, down to half a degree below normal. Today, we're right here. Actual temperatures was at 0.3 degrees. That's about what the model's saying. And supposedly going down to 1 degree below normal. I mean, nearly 1 degree as we get into, what would that be, September, October, November, and December, and then starting to recover some. So theoretically, again, La Nina, half a degree below normal for 5 consecutive 3-month periods. We think we're going to be in La Nina. We could be wrong, but we're siding with this model for now. Either way, just based on the cool upwelling thing that's going on right now, there is no way we're going to move into some favorable great jet stream pattern come this winter, barring short of a complete miracle. If anything, last winter looks like a harbinger for what's going to happen this winter, only more so of the same, which basically means dry, not a lot of surf, and probably pretty windy as well. So that's the thoughts. Let's go wrap this up. So the good news is there's actually some, no swell right at the moment, but there's, I think, 2 little southern hemi swells in the water on their way pushing towards us. Rideable surf, make the most of it. Wind swell for sure, plenty of wind swell during the week. And then the models suggest potentially 2 more southern hemi swells pushing towards Hawaii, sort of more sideband energy. And then probably a little bit better at California, but Chile, Peru, probably the prime focus. But either way, swell, it's not dead. So let's be clear, La Nina does not mean a complete lack of surf. It just means fewer storms, not as strong storms. They don't last as long, and they typically don't produce as big a surf. So if we were to make a guess on this winter's forecast, Yeah, there'll be surf, but it'll be smaller than normal, won't last long. The high pressure in the Gulf of Alaska will be stronger than normal. There'll be a lot of windy days. You'll get some surf, and it'll be completely blown out. So, I mean, you just got to prepare yourself. Also, point two, not a lot of precip in California. The jet stream will probably be shunted well to the north, pushing into the Pacific Northwest. Probably record rainfalls. And maybe that's a little bit too strong, but more precipitation than normal. The question is it in Oregon, is it in Washington, or do you have to go the whole way up into Canada? In terms of snow chasing, yeah, that might be good. You just got to plan, assuming COVID doesn't lock everything down. We're not going to go down that rabbit hole tonight. But, you know, plan appropriately, manage your expectations, be safe, and, you know, this is the way it goes. We go through good times, we go through bad times. Now's a bad time, and that's just life. But that doesn't mean there won't be surf. It's just not as good relative as it could be. So that's it for this week. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, click the subscribe button. You'll get an email notification. If not, you can view the emails on our view the videos on our website, stormsurf.com. All the material that is presented here, you can view there on the site as well. Follow along. We'll give you an update again next week on Sunday about the same time. So thanks for watching. We'll see you next week, and be safe and have fun. All right. Thank you.